Have you ever wondered how hackers reverse engineer firmware, or how we can quickly spot vulnerabilities in devices? Well, today I'm going to show you how you can automate firmware analysis using a powerful suite of tools. This could save you hours of manual work and could even expose security flaws faster than traditional methods. Stick around and let's dive right into it.
Welcome to Fresh Forensics, your go-to destination for everything Linux.
Hey everyone, welcome back to the channel. We're over on my GitHub page. This is the starting point for all of my GitHub repositories, and this is located at github.com/DouglasFreshHabian. If you've never seen any of my previous videos, let me take a moment just to quickly introduce myself. I'm Doug. I'm a Linux system administrator, and I am deeply passionate about all things Linux. Over here on my GitHub page, you can actually verify my certs. I have a couple of them, Linux Essentials, as well as the LPIC 1, which certifies me as a Linux system and server administrator. I have numerous GitHub repositories, but the one that you're going to be interested in for this video, as well as the others in this series that pertains to reverse engineering or IoT hacking, this Doorbell, is going to be a repository that is called Doorbell. And if you click on repositories at the top, it will take you to this page where you can view all of my current repositories. Now, over here on the GitHub repo for Doorbell, you can see the progress that we have made thus far. There are links to my previous videos. You can follow along with pretty much everything that I have done up to this point. There are links that will take you to Amazon if you're interested in purchasing some of the tools that I use in the videos. There's an entire methodology over here on this GitHub page. We've learned a lot about this Doorbell. If you haven't seen the previous videos, go take a look at those. That'll get you caught up to where we're at now. And if you really want to get hands-on, then go over this README on the GitHub page and it will walk you through everything. Now I'm going to quickly head over to another one of my repositories, and this one is called Fresh PDF Library. And this is essentially an online library of PDFs that I reference a lot. There are a lot of PDFs inside of this repository, but there's one in particular. It is called the Firmware Security Testing Methodology. It originates from OWASP. You can get it from one of their web pages, or you can get it from my PDF library. But essentially, this is a very important PDF, especially for this particular series, because it's kind of what I have been following as a format for all of the previous things that I have done. And there is a checklist inside of this PDF. Go get the PDF if you don't already have it. Over on my GitHub page for the Doorbell, if we scroll down to the section titled Ongoing Reverse Engineering Efforts, I have the same checklist that you can find in the PDF. And this is everything we have done so far. We did information gathering and recon, obtaining firmware, analyzing firmware, extracting the file system, analyzing the file system. We analyzed it manually. So what we're going to do now is we are going to automate this process of analyzing the file system, and we're going to leverage various tools and scripts. So let's talk about the tools that we're going to use to automate this analysis. The first one needs no introduction. It is a very, very well-known tool, and that is LinPEAS, which stands for Linux Privilege Escalation Awesome Script. This LinPEAS script is just one script in a suite of other scripts. You have ones for Mac, you have ones for Windows, but we are concerned strictly with LinPEAS for Linux, which is traditionally used for automating the process of enumeration in regards to, or as it pertains to, Linux privilege escalation. But we can also use LinPEAS to automate our analysis when it comes to firmware and the file system. Links will be in the description for everything. So I'm going to head over to the releases page to get the latest version of LinPEAS, just updated last week. I'm going to right click and copy the link. And I'm going to go back down to the command line. So I am inside of the extracted file system of our firmware image. This came from an inexpensive video doorbell that typically sits on the front of your house and watches your neighbors or the street or whatever. I'm actually going to make a new directory just to store everything that we are doing. And I'm going to call it YouTube. I'm going to cd inside of that directory. And now this is where I'm going to work out of, a fresh and clean directory. So using wget, I'm going to grab that script. Here it is. It's called linpeas.sh. Now I'm going to make that script executable. And we are ready to go. I can run linpeas and do -- help, and that will pull up the help menu for the tool. It's got a nice little colorful help menu. What we're going to be interested in is a little bit further down, and it's actually titled Firmware Recon. So we just give it -f and provide it with the path to the file system and run the tool. So let's go ahead and run it. We're going to do linpeas.sh. I'm going to do -f and then give it the path to that extracted firmware file system. And that is going to be located a few directories deep into my file system. Let's just go ahead and skip ahead to that point and let's hit enter. So the script starts up. We have this ASCII art, which you can pass -q on the command line, and it will skip printing the ASCII art to the screen if you so desire. Utilizes a legend, a coloring scheme in order to let you know what you should be looking at as far as severity wise. You will get some basic information back that actually pertains to the system that you are running this script on and not the file system that we are actually looking at. But once you get past that initial point, everything thereafter will strictly pertain to our target for analysis, which is the extracted file system of the firmware image. And it has finished. So let's scroll back up to the top and take a look at the results. Once we get past basic information, we get to processes, crons, timers, services, and sockets. One of the things that's really nice about LinPEAS is it doesn't just show you its findings or what it's looking for, but it also always references the associated material so that you can go and read up and learn more. And this is, of course, the book.hacktricks.wiki, which is a very, very valuable source for information for all things cybersecurity related, whether it be hacking or enumeration or firmware analysis, pretty much anything and everything. So if we continue to scroll, it hasn't found much of anything yet, and it is looking. And we get to our first interesting finding, and that is possible private SSH keys. And it gives you the path, and it is pointing to this file located inside of the extracted file system in user bin, and the binary is chiop. Not sure how that's pronounced, but in a separate terminal, if we navigate to that binary, this is the location of it, and this is the binary it's making reference to right here. And if I run the file command on that, we get back that it is an ELF 32-bit executable, ARM architecture, dynamically linked, stripped. I can run the strings command on that. And after running strings on this, there's quite a bit of information that we are getting just from using strings. And this particular section right here, this looks kind of promising. Like this might be maybe what it was hitting on. Okay, So going back to the output of LinPEAS, we'll continue. It is searching for a lot of things, but there's not a lot that is coming back for this extracted file system. Here are executable files, potentially added by the user. And then we have, at the very end, we have password information that was found. And this obviously, this is something that we already found previously when we manually looked at everything, and we were able to crack the password. So it did successfully pick up on that. So that is linpeas.sh. This can be used not just for enumeration and privilege escalation, but it can also be used to automate firmware analysis. Let me know if you guys have been successful in using LinPEAS for firmware analysis in any IoT hacking projects. I would be curious to know what your results were. Next up in the list is going to be a tool called FirmWalker. I'm over here on the GitHub page for FirmWalker. That is located at github.com/CraigZ28/FirmWalker. Links will be in the description. Now this is a script for searching the extracted firmware file system for goodies. Amongst other things, it searches for things of interest such as what you see here. Very simple. It suggests to run chmod 0700 on the script, and then you're going to run the script from outside of the root file systems directory. You're going to run it on that root file system, and it's going to save the results to a file called firmwalker.txt. Pretty simple, pretty straightforward. Now there is actually another version of this script, and it goes by the same name, but it's by a different author. So it is going to be on a GitHub page that is at github.com/scriptingxss/FirmWalker. I mean, it pretty much looks identical. I don't see anything that looks different. The name is the same and everything, but if we go back to the first one, the more well-known author and version of this, and we click on the actual script, I open it up in another tab. If you look at the script, go down to the bottom, it's 182 lines long. Well, if we go to the one by scriptingxss and do the same, this version is 238 lines long. So it's considerably longer. So I'm going to click on the green button that says code, copy the HTTPS URL to the clipboard. I'm inside of the YouTube directory that I created that is still holding the linpeas.sh script. So we're going to do a git clone on that URL. Once it is finished, cd inside of the FirmWalker directory and do an ls, and this is what it looks like. The FirmWalker script is already executable, but if you remember from the README, it suggested that we should run chmod 0700, and if we do an ls-l, you can see what the current permissions look like. So when we run chmod 0700 on that script like that, and then rerun ls-l, you will see the difference in the permissions, and that is for a real reason. So make sure that you complete that step, and then we can go ahead and run FirmWalker on the path to the root file system, the extracted root file system from the firmware image, and hit enter. And you can see everything it does. It spits it out to the screen, and it has finished just as quickly as we have started it. So now we can scroll back up to the top and we can look at everything that was done. So it searched for password files. It found them inside of directories that we've already looked at. Searched for SSL related files, files ending in .key, sir, pem, cert, etc. Searched for SSH related files, things with host keys or RSA keys, etc. Then it searched for configuration files, and it found all of the configuration files, and it has them listed there. And then it found various shell scripts. Then it searches for patterns inside of files, and it found some files that seem to have some patterns of interest. And yet again, one of those files was that same binary that everything else seems to be pointing to. And here's another reference to that same binary a couple times. That same binary is referenced as possibly containing SSL information or a private key or some form of a secret or a token. And when we get to this point in the script, I believe we're now getting into things that this script is doing that the other script does not do, such as searching for band C functions or searching for string copy. All of these additional things I don't think that previous script is doing. So it is definitely taking the analysis much further, looking for mem copy, and it's finding stuff too. And we have a listing of IP addresses as well as URLs and email addresses. It's a pretty good script, very fast. And everything that was just printed to the screen is also going to be inside of a file that now exists that is called FirmWalker.txt. And if we were to open up that file, it's going to basically be identical to what we just saw on the screen, except with a little bit of color to some of those lines, but same exact content. And if you're curious to know how many lines that was, it was 571 lines. If you were to run the other version of this script on the same destination, you would end up with roughly half of that amount of information. The next tool that we're going to take a look at is more like a suite of tools, and this is ClamAV. This is an open source antivirus engine that can be used for, amongst other things, detecting Trojans, viruses, malware, and other malicious threats. This is cross-platform. You can install it on Windows, Mac, and Linux, and it has a vast amount of documentation. It has a GitHub page. This is what the GitHub page looks like. And from here you can navigate to other links to do other things, such as installing it. And over here on the install page, it will direct you as to how to install this depending on which system you are on. Now, I am using a Debian-based system, so I would be using APT. Now, if you too are using a Debian-based system, then you can do a search by running apt search for ClamAV. It'll pull up numerous things. There's wrappers and other packages that build off of ClamAV. There's a lot of stuff here. You have the docs, a daemon. You have fresh clam, which is something that is needed as well. But the main thing is going to be ClamAV. You can see that it is installed on my system. It's an antivirus utility for Unix command line interface. Now, if we do apt info ClamAV, it will pull up a lengthy description about this. It can be used for mail servers, for attachment scanning, all sorts of things. And it can be used for scanning firmware images and the file system that we extracted. Now, for scanning to work, a virus database is needed. And there are two options for getting it. We're going to be using the first one, which is ClamAV Fresh Clam, that updates the database from the internet. So now we can do apt info on ClamAV-Fresh Clam. This package contains the Fresh Clam program and scripts to automate virus database updating. So to install both of these at once, you can run the command sudo apt install ClamAV and ClamAV-Fresh Clam. I already have both installed. Once you have them installed, the main thing that you have to do is you need to run fresh clam to update that list of virus signatures. And once you have these utilities installed, if you're using a shell similar to mine, such as the wonderful fish shell, that have capabilities such as this, you can run, you can begin to type clam and then just hit tab, and you get that auto completion as well as the suggestions, and you can see all of these different things that comes with this. So for example, we actually have something similar to top or HTOP that comes with the clam suite of tools, and that's called ClamD top. It's kind of interesting. So if you run it, this is what you get. It's an ncurses based monitoring system that will actually monitor any instances of ClamAV that are already running. Pretty cool. Hey, it even uses ASCII art. Very cool. Okay, running ClamScan. So if we pull up the help menu for that by running ClamScan with --help, there are quite a heavy list of things that you can do with this. And we are not about to get into any of that. We're going to keep this very simple, but it is a lot. There's a lot you can do with this, and it's very interesting. So for example, you could use --bell, and you could actually sound a bell on virus detection. Pretty cool. If you want to print only infected files, you can do --infected. Of course, you can increase verbosity with --verbose. We're going to run this with --recursive, and that is going to be used to scan subdirectories recursively. So we're just going to run this on the root directory of that extracted file system, just like we did with LinPEAS. I'm just going to run sudo clamscan --recursive, and then give it that path and hit enter. Doesn't take very long. At the very bottom, it actually tells you the start and the end time. This took 15 seconds from start to finish. We go back up to the top. Because of the way we chose to run this, there are options that you can set to make it so that it does not spit this out, but it printed out every single thing that it scanned and the OK at the end. And then all the way at the bottom, you get a scan summary. And this is utilizing a database that has a lot of known virus signatures inside of it. So we're talking about 8,706,231 known virus signatures that it is leveraging. It scanned 42 directories, it scanned 143 files, and ultimately it found 0 infected files. And yes, it took 15 seconds from start to finish. Though it didn't find anything, it's actually a good thing. And more importantly, now you know that this is yet another tool that you can use, not just for what most people think it's used for, but you can also use it for firmware analysis and scanning the extracted file system for anything potentially harmful. The next tool that we're going to be looking at is none other than ChatGPT. Yep, believe it or not, you can use ChatGPT to help interpret the results. You'd be surprised how useful AI can be when analyzing complex firmware or the file system or even programs that you are able to see the code of. And that's what we're going to do. I'm going to show you a quick example of that. So I am in the root file system of our extracted firmware image, and we're going to cd inside of the Etsy directory, which is a very important directory on any Linux-based system, as it stores, amongst other things, configuration files. And we're going to cd inside of another directory. That directory is initd. This is a very important directory inside of an IoT device because this is where everything that is being initialized at the beginning is going to be found via initialization scripts. Every one of these is going to be a bash script. So we're able to look at the code. This is not something where we have to get out Ghidra or something and get into complex reverse engineering of a binary, using a disassembler or something like that. We're able to see the code. If I cat out one of these scripts, for example, such as ADBD, we can see every line inside of this program. But what if you don't understand bash? Or you don't understand bash well enough to be able to read and follow along with what is happening here? Well, that's where AI comes in, and we can leverage ChatGPT for this. So I'm simply going to copy everything that you see here. It's not a very long script. And I'm going to come over here to ChatGPT. Now, you don't even need to be logged in for this. If you can get to a ChatGPT prompt and it doesn't redirect you, you don't need to be logged in. Just paste a script in. I happen to be logged in this instance because of previous work I was doing, but all you're going to do is paste the contents of the script into the prompt. Nothing else required. No explanation, nothing. Just hit enter. So we get this summary of the script. It tells us that this is an open WRT style init script that configures a Linux-based embedded device to expose ADB over USB utilizing function fs. And it starts up the ADB-D daemon. And it goes on to explain very specifically everything that this script is doing, from mounting to extracting, starting the daemon in the background, etc. and so forth. And it tells us that it's typically used where ADB access would be needed for development or debugging over USB, similar to how Android devices expose ADB. But wait, there's more. There's always more. As a little bonus, I'm going to show you another script. I'm not going to go into great detail about it because this gets into just a little bit more than I want to cover. We're now stepping into binary analysis or reverse engineering binaries. And that can get a little thick, but nonetheless, I want to point you to this incredible resource. It's another bash script, and it automates a lot of work that you'd have to perform manually. It's over here at github.com/perturvis/checksec.sh. And this is a lightweight and portable bash script that helps assess the security properties of executables, processes, and system configurations. It provides insights into applied security mitigations and system hardening measures. I'm going to come up here to the green box, copy the HTTPS URL to the clipboard, go back down to the command line. Inside of the YouTube directory that I've created that is now holding FirmWalker as well as LinPEAS, I'm going to do a git clone of that repository, cd inside of the newly created checksec.sh directory, and do an ls, and that is what we see. So the main script is checksec.sh. However, there are additional scripts inside of the tests directory that the main script leverages. So we can go ahead and run checksec.sh with --help, and it does have a help menu. Now, when you're running this script, you're not running it on a root file system or a parent directory like we have with the previous scripts. This one's a little different. You are running this on a specific binary. So we're going to run this on that one binary that keeps popping up in everything that we do, and that is that binary that I'm pronouncing as CHIOP for lack of a better understanding of it. So we'll go ahead and run /checksec. I'm going to do --file equals, and then give it the path to that binary and hit enter. And if you have ran it correctly, you will see something similar to this. So all of these different checks that it performs are all checks that one might perform manually. So again, this gets a little deeper into things than I want to go. We're now stepping into binary analysis or reverse engineering of specific binaries when we are talking about looking for stack canaries and symbols, and if it is utilizing pi. But nonetheless, for people who are familiar with this concept, this is a great script that automates a lot for you. And with that being said, we're going to go ahead and leave it at that. If you found this video helpful, don't forget to like, comment, and subscribe for more Linux, cybersecurity, and hacking content. And as always, keep learning
and stay fresh.
I'll see you in the next video.